has been on everyone's mind. Can machine be creative? So in the synopsis, what we find, as architects transition from creators to directors of algorithmic options, this shift demands a redefinition of creativity and innovation in the architectural process. Some intellectual intellect criticize AI because it has not got feelings and emotions. But should we really care so much about feelings and emotions? If my coffee maker can make my coffee properly, does it matter whether it go feelings or emotions? Does it matter whether this image is produced by a highly sensitive human designer or an utterly insensitive machine? In the impact of architectural form in educational institute, the standard courses of architectural education through institutions such as the École des Beaux-Arts, MIT, and Bauhaus support the significance of mastering tool in the establishment of architectural theory and practice. All of these institutions relied on various architectural approaches that pointed at different philosophies of design linked to the tool as well as method of the period. Tools directly influence architectural aesthetics, pushing the boundaries of design possibilities while simultaneously embedded specific biases. Our findings, the findings reinforce that tools are not merely passive implements, but active forces reshaping architectural languages and practice. We try to highlight the duality of tools as enabler and inhibitors, emphasizing the socio-cultural forces behind technological adoption. The conclusion calls for a critical reflection on the evolving role of tools, advocating for a balance between technological potential and human creativity to preserve architecture's cultural and artistic essence. We have gradually forgotten the essential elements that once defined our lives. Analog phones, we use this thing with phone number index, camera with film reels, postcard, paper ticket, all seamlessly replaced by the omnipresence of the cell phone. We are scared. What will happen to the architecture? Will it replace by anything? Then I ask ChatGPT, will AI replace architect? And I got the answer. AI will not replace you. A person who is AI will replace you. And I was relieved. Canadian philosopher and father of the media studies, Marshall McLuhan, delivered an insightful comments. We shape our tools and thereafter our tools shape us. I think it's very much relevant for us also. And we speculate. What architects need to design right now is not another building, but the very future of their profession. And AI tools will surely be the part of that future. And I think it's the wake-up call for us. Thank you.
Thank you, Mr. Mannan. I ask you to stay there for the discussion, not now, after other interventions.
Okay.
Well, now I call Ms. Efrosini.
Hello.
Hello. The presentation will be on the experience of architectural spaces, a pedagogical experiment using game engines. Thank you.
Okay, let me share my screen. Where is it? So, okay. Can see it. Okay, it's great. It's actually really good. It's great. So, can you hear me?
Yes, we can hear you.
Okay, great. I'm really happy that I'm able. I'm able to present this paper with you. Unfortunately, I was not able to attend the conference. It would be great. I'm sure I missed a lot of inspiring presentations. Anyway, I would like to share with you some thoughts and results that are related to a pedagogical approach, focusing on the experience of architectural spaces with the use of game engines, integrating the use of game engine and scientific thinking to enhance a student's understanding of the embodied experience of architecture. This was an undergraduate optional module that took place at the architectural department of Frederick University in Cyprus. But before describing in detail the course, the module, I would like to present a brief introduction on the subject and the difficulties of integrating scientific thinking and technological tools into design thinking. So, so a key objective in general of most architectural projects is to create context that support and sustain human living. But to do that in a way that responds to different human needs, we need to look deeper and understand better how different environmental contexts that we create through our design decisions impact the human experience, including the cognitive and psychological and behavioral dimension of the experience. So this led to the emergence of the fields like environment and behavioral studies or environmental psychology in the late 60s, as a response to the lack of explicit knowledge on these matters. The objective was to develop empirical-based understanding of this relationship between our psychological and behavioral patterns and the natural and built environment. So, but a genuine dialogue between different disciplines of science and design requires overcoming several challenges. First, there is the disciplinary knowledge gap, because since science and design evolved two seemingly different modes of thinking and producing knowledge. So on one hand, we have the factual experimental knowledge that is generated through systematic empirical observations. And on the other hand, we have the tacit knowledge that is gained through experience, much like the knowledge that the potter has. It's a kind of a practical knowledge gained through reflection. And so to foster effective reflexivity and dialogue across these areas, we need to create a synthesis of these two disparate paradigms to find mutual inventive ways of doing science and of doing research and scientific research, because it's often the case that the research agenda are driven mostly by the disciplines we get have a higher percentage of funding, of getting funded. So it's a challenge to find ways of driving mutually, of creating mutually driven research agendas. Furthermore, there is a research practice gap. So according to a survey focusing on evidence-based practices in architectural and urban planning, 80% of the respondents who were design practitioners acknowledged the need for evidence in their design practice, but 68% of them reported that they never or very rarely reviewed the literature. So this is perhaps due to the fact that design practitioners have limited access to the findings of academic research, and they often lack the necessary sophisticated skills to critically evaluate the literature, since they are often not familiar with the scientific methods and the empirical approach to the generation of knowledge. And they also lack the skills to use the available digital technological tools that could facilitate such inquiries. So potential pathways to bridge these gaps is to focus on the relation and an active aspect of architectural experience, on the relation between the behavior and the environment. And this can be facilitated by using game engines and advanced extended reality technologies as research and educational tools. Both of these requires rethinking how the traditional architectural education and restructuring some aspects of the traditional approach. So I'm just going to zoom into these 3 points briefly. So theories of embodied and enactive cognition and direct perception on one hand, and the long tradition of architectural phenomenology on the other hand, they offer a great promise for enhancing this dialogue between science and design. This is because the theories of 4E cognition, that is, theories that acknowledge cognition as embodied, embedded, culturally embedded in a context, enacted, extended, and affective, they emphasize exactly the role of the environment-body interactions in shaping cognition. So they highlight the role of the environment. So cognition is not solely located in the head, but in our interaction with the environment. So the built environment shapes the experience and the behavior. Furthermore, the concept of neurophenomenology, for example, which is very closely related to the enactive approach to cognition, brings to the foreground the first-person subjective experience, which is the main focus of phenomenological investigations. So phenomenological explorations, they focus on the embodied experience of architecture, how spaces are felt, how they are sensed, how they're lived, and again on the interplay between the brain, the body, and the environment. And this alignment offers a great opportunity for developing and overlapping research agendas that foster more phenomenologically driven or phenomenologically oriented methodologies and experimental frameworks. And that's potentially leading also to findings that are more relevant to our architectural or urban design practices. And research that explores this relation can benefit from game engine and extended reality technologies, which can be used as research tools, but as educational tools as well. As research tools, they enable researchers to explore the impact that different environmental factors have on human experience, on the behavior, and on perception. And they allow the design of control experiments and data collection. As educational tools, they provide interactive environments for students to experience and evaluate their designs from a first-person perspective. They facilitate the visualization, communication, but also the critical reflection through pre-occupancy evaluations of the spaces that the students conceive. Furthermore, they enable multiple teaching strategies, focusing on different aspects, and they can be used for different modules, like spanning from design studios to science or theory lecture-based modules. So they offer a great potential in education as well, not only to visualize the design proposals in design studios, but to integrate the empirical investigations into architectural education, such as capturing movement data based on first-person experience and visualization, or comparing these data across different design solutions, or comparing across different users or types of users. But this potential is relatively unexplored in cases where they use extended reality tools in architectural pedagogy. So these technological and theoretical advancements, they challenge the traditional approaches to design education. The theories and principles of the 4E cognition, they encourage a shift from the conceptual explorations toward a more embodied and enactive perspective, to a more relational approach to architectural space. Or as Sarah Robinson explains, is We ask not what the building looks like, but rather what it does, what kind of interactions does it enable, afford, provoke, intensify. Furthermore, integrating cross-disciplinary explorations can complement the traditional approaches because it offers students the opportunity to engage with research inquiries and actively develop informed perspectives through experiential learning. For example, evaluation research offers a deeper evidence-based understanding of how the built environment impacts users and involves systematic data gathering, analyzing, and interpreting the relevant data. So within this context, the pedagogical experiment that I will describe in the next few slides was an attempt to find innovative teaching strategies that respond to the need for cross-disciplinary explorations and to the need to integrate an enactive approach to the architectural experience. So the module involved 10 undergraduate students. It was an optional module, and the teaching and learning activities were developed over 13 weeks. The focus was on the experience of architectural space and on human behavior, and the objective of the module was to familiarize students with the scientific empirical method, and also to enhance their ability to use game engines as tools in the design process. So the module, just a brief description of the module content. The introductory lecture of the module included an overview of the use of extended reality technologies in architecture and its potential as a research tool, and also of the contemporary work on architectural phenomenology. Then the students, they were introduced to the scientific way of thinking. So during the first stage, students had to choose an existing 3D model that they already had, either through previous courses of digital tools or through the or in their design studio. And they had to think and assess how the architectural space is experienced, and to think how specific changes in spatial qualities, in spatial relationships, or in different features may affect movement or behavior, or in the architectural experience in general. So they had to formulate what-if scenarios. In that sense, they had to formulate hypotheses that they were going to test. So after this first stage, they had to prepare a modified version of the existing 3D model in order to test this hypothesis. So they had two models, the original and the modified version. So students' work was then focused on producing the virtual environment as a photorealistic simulation of the architectural environment as close as possible. And then they had to collect movement data from different participants, that is other students, for each case, which they had to, and they had to use this data to create visualizations showing the movement patterns in relation to the building layout, and also present their reflections and interpretation. To evaluate students' experience, I conducted a post-study survey 4 months after the end of the course. A questionnaire was designed in order to capture how students evaluate the experience of the course, how the course affected their approach to design, and how they evaluate the use of Unity as a tool in the design process in relation to more traditional modes of architectural representation. So students' experimental design exploration were focused on specific elements of the environment and were based on hypotheses that capture embodied and enactive aspect of the architectural experience. The table here shows the 5 groups, and the research focus on the hypotheses that they formulated, the building that they use. And in each of the 5 experiments, participants has to follow a different task description, which corresponded to the specific hypothesis and the use of the specific building. So, for example, in the exhibition, in the case of an exhibition, the gallery building, participants had to enter the gallery and view the exhibition photographs. Or in this case of the residential building, participants had to perform their morning routines of a usual day, for example. The participants were able to navigate through the environment from a first-person perspective, and they control their character using the common computer game inputs. So I have included some photos from the virtual buildings that the groups constructed. So group A, for example, this one focused on the effect of natural light on movement and exploration patterns. They modified this characteristic element of the Coscino residency by Adadayanto, and they changed the big opening in the studio room and created a large opening on the opposite side of the house. Or group B focused on how different arrangement of exhibition panels have a different effect on guiding visitor movements. We will see this in the plan, so to understand better. So in this case, yeah, it was the hypothesis was that the arrangement of the exhibition panels guided visitors' behaviors. In another group examined how everyday household practices are supported and shaped by the partitions and arrangements of the residential dwelling. So these groups, the model was inspired by Farnsworth House, and the students wanted to understand the effect of the central core on the occupant's daily life. So to do that, they compare it with another modified version of a more partitioned space. So these were what students delivered, like in the final presentation. They presented the specialized patterns of movement and their reflection and interpretation, which was then followed by a group discussion. So the first is some student halls. It was a student's project on a design studio, and they wanted to explore the impact of an outdoor staircase on exploration. So I think in this case, the scenario was you're looking for your friend. She might be in the cafeteria or in the gym, so you had to find her. So participants, they took this role and they explored the environment, having this intention in mind. In the second case is the exhibition space, the gallery. So we can see that there is a difference in the patterns of movement. And this is the Tadao Ando residency, where I have also included students' reflection because I think it's an interesting reflection. So they changed the orange. I don't know if you can see my cursor. So here they changed this wall as we've seen in the previous renderings, and the orange they indicate the changes. So they wrote in their presentation that by changing the experience of the space through light, the player's movement, behavior, and experience of the architectural space is affected. There is a change in the player's behavior as they do not choose to explore spaces with an inadequate lighting, but instead choose to explore bright spaces. In indoor spaces where there is light, players' movement are more carefree, while in dark spaces, they are more linear and absolute. Another interesting reflection is from this residential experiment on the residential building and on the effect of the interior and spatial arrangement of movement patterns in everyday routines. So the students wrote that in conclusion, the differences between the two design versions of the dwelling significantly affect differently the daily experience of the occupant and the functionality of the space. In version A, where the resident follows a circular route moving around the house, is more comfortable, efficient, and social. For a couple, as they explain. Easy access to a room facilitates daily activities, making living more comfortable and practical. In version B, the resident has to travel long distances to move from one room to another. The sense of privacy and autonomy is enhanced. So the experience of the first part of the questionnaire, just to move on how students experience this educational experience and scientific thinking. So the first part of the questionnaire was focused on the general learning experience. The overall experience of the module was rated as very good or excellent. And they reported that the goals of the course were comprehensive. The content of the course responded to these goals and had cohesion, and the evaluation methods responded to the content. Almost all students agree or strongly agree. However, several students were not able to decide whether the course was useful for their scientific development, but I think perhaps this question was not very clear to them what we mean by scientific development. Because as we can see here in the second part of the questionnaire that was designed to capture how students perceive the impact of the course on their approach to design and the integration of scientific methods, the students confirmed, so they agree or strongly agree, that the module helped them to better understand the scientific methods and the potential role of the scientific approach in design practice. The majority of the students also agree or strongly agreed, 83% of them agreed that the course contributed to a better understanding of the relationship between architectural spatial qualities and human behavior. So next, the students responded to a questionnaire regarding how likely it is to incorporate designerly ways of systematic inquiry into their design projects. So more than half of the students reported that it is likely or extremely likely to use these methods in future architectural design competitions. 43% of them reported that it is likely or extremely likely to implement these methods in their future architectural practice. But implementing these methods in design studio, and especially in the context of their final year design project, was generally considered less likely. Just 10% of the students thought that it is likely to do that. Perhaps they evaluate well the time-consuming, that is a time-consuming process, and of course requires more advanced skills or more practice with these technological tools in order to do that immediately. That's my interpretation. So students in generally did not feel very confident in being able to implement in the future the skills and knowledge they have learned. So students who felt slightly comfortable with the learned skills they could not decide on the likelihood of using these modes in their future practice. So they couldn't see themselves using these ways of inquiry in their future practice because they didn't felt comfortable with what they learned. However, the students who felt moderately or very comfortable with what they learned, they reported that it was very or extremely likely to do that. The first part of the questionnaire was focused on the evaluation on the comparison of Unity as a tool in the design process and in relation to the traditional tools of architectural drawings and models. So most of the students, 86%, reported that they think that game engines are more effective in evaluating the impact of design and in exploring spatial qualities. This is the blue bars. And and also in exploring the spatial qualities and their impact on architectural experience. For communicating and presenting design proposals and morphological aspects, students reported that traditional tools are more effective. And these are the purple lines. So they reported that the 57% reported that communicated and presented design proposals traditional tools are more effective, and 71% reported that morphological aspect can be more effectively communicated through traditional tools. However, in communicating central conceptual ideas and design principles, as well as aspects related to possibilities of actions afforded by the design proposals, both tools were considered equally effective. So 70% of the students said that both tools are considered equally effective. And these are the green long bars. So in general, the results of the evaluation questionnaire show that students acknowledge the potential of the game engine as effective tools for evaluating the impact of design on human experience and the potential of the scientific method in advancing things. However, they didn't feel very comfortable regarding the skills that they acquire, although they were able to complete the group projects and the data collection and visualization. So a possible interpretation is that they needed to become more familiar with Unity and with the game engine and the scientific thinking, and the scientific method through practice during an extended period of time to feel more confident. And this reflected in one comment by a student saying that perhaps if we had more available time, we would be able to learn more regarding the program and absorb it better. In other words, we will become more familiar with the program. Because I believe it could help me perceive better what I create, and certainly others could perceive my designs work better. The same student reflected that it's definitely an advantage that I had the opportunity to learn something new and interesting, something different from the core courses. So rethinking architectural education under this cross-disciplinary lens can enhance the student understanding on the impact of the environment on behavior and cognition, but also requires rethinking how students engage with the scientific method knowledge. Because on one hand, we have the designerly ways of knowing. It's the conceptually messy process of architectural design, which involves a very distinct and unique form of knowledge that enables design to deal with ill-defined, wicked problems, as opposed to the scientific, clean investigation that deals with well-formed problems, which are tame. So while scientific approaches are analytic, design is constructive and involves exploring a range of satisfactory solutions that are good instead of bad, and as opposed to a hypothetically optimal solution that is correct or right or true, as opposed to wrong. So there is a difference there, and it's important to acknowledge that the methods used in cognitive and behavioral sciences may not always be well suited for the phenomena that concern architectural research. So as Sarah Robinson notes, where the scientist is concerned with small differences that may be statistically important, designers need to understand patterns that have a larger impact. So we must accept that our design solutions might be based on research that may not be perfect, but may be good enough. And we need to develop experimental techniques that consider such pragmatic goals. So to integrate these two different forms of thinking requires imagining and developing more designerly modes of doing science, let's say, or doing systematic design evaluations. So to conclude, some tentative conclusions is that integrating technology, science, and design allows future practitioners to develop a critical understanding of how a design decision impact user behavior, which may lead to more inclusive human-centered approach that embrace a diversity of bodies and user experience. But to do that, we have to embrace the messiness of design knowledge and develop systematic design evaluation that allow practitioners and students to get a feel for the behavior of a phenomenon through virtual models and experiential learning. So thank you for your attention. That's it. Stop sharing the screen now.
Well, now I call Joaquim Flores, make the presentation on geographic information systems in architecture and urbanism education.
Thank you very much. I'm going to present you this about the introduction of geographical information systems in architecture and urbanism education. It's not a scientific paper, it's just the experience of some years working. We can consider it as a kind of proto draft for a research, a future research, but basically is GIS in architecture and urbanism education in Portugal, and professional and teaching experience of 13 years. 13 years of teaching experience using GIS. I always use this analogy to my students. I use it in the workshop. This is a little bit tied with the workshop that we have done, is that geographical information system is like a cooking robot, okay? They already do a lot automatically, but they need, of course, ingredients. In the case of GIS, is data and information. And then you have to have a cooking recipe, crossing, analysis, the information. And finally, you want to obtain a meal. Maps, reports, 3D models, whatever. Of course, also, you first start by the meal, what you want. Then you try to find the right cooking recipe and what ingredients do we need. This is the concept of GIS, which is integrator of information and how can I use the information. That's why it's much related to urbanism and planning more than the idea of project. And naturally, geographical information systems are traditionally used by geographers and urban planners. That's why here is the question, why integrating GIS in teaching in architecture makes sense to do that? The question is related also with the scope, professional scope and teaching scope, which is also related, I have discussed this with some geographers, with territorial scales that we normally work. It's regional in here, it could be national, very large scales, of course, but I just put regional in here and where geographers probably feel more comfortable working with. But when we go to urban, to project, of course, architects, I don't see a geographer trying to draw a project, urban project. And also, this is related with the terminology and what we do, plan, project, and also with the terminology that we use, map, drawing, and of course, in the software that we use, GIS, and CAD BIM. So, of course, GIS is naturally related with analysis of the territory with the planning. That, when we pass to education, and especially in the case of Portugal, is more complicated because we don't have things clear here like there are in other countries. Urbanism is traditionally taught in the courses of architecture, not as an independent discipline. For instance, I have in here the example of UK, where you have architects, where you have urban planners, where you have urban designers. In here, architect can do everything. But at the same time, geographers also have a place in urban planning. Civil engineering with the specialty of territorial planning also do that work. So it's a little bit confused in terms then of professional practice. But when we refer to architecture, the use of GIS in architecture education, normally, of course, we refer to the disciplines of urbanism. So I've done, which is the prototype of research, using the case of the Portuguese courses, 18 architecture courses that we have here in Portugal. A very simple analysis of the study plan of these courses. From the 18, only 5 mention GIS in the study plan, 27%, but only 3 explicitly refer the use of GIS in those disciplines, which is 16%. However, something which was also interesting is to see that geography, sometimes divided in physical and human, is normally the introductory discipline for urbanism, okay? Sometimes it's more heavy geography, and other times more close to urban analysis and introduction to the next disciplines on urbanism. So the further research I will do relating to this is to compare these GIS Portuguese courses with the top 20 world, according to the rankings, and also to do a direct survey to schools and to students to see effectively how this is going to work. Now, the most interesting, which is the core of what I want to present you, is the professional and teaching experience that I present here, because also we'll show you the process of I, as an architect, using GIS, which is different from a geographer using GIS, and how I have done this tour along all the disciplines I gave. Also will show you the different perspectives. This started in 95, 97. I think with what architects normally want GIS to do. It was urban planning. I was in charge of doing the survey of this city, 1 record for each building. And at the end, we have to do thematic cartography, okay? We all know how this works, for instance, with AutoCAD, a polygon for each building, a edge, and then changing the edge. For each one. That's why I'm interested in GIS. How can I do this automatically? I could not do it. 95, 97. Esri, of course, already have many software, but it was impossible to reach Esri software. But I think I show you this because it's the aim of the architects. I produce this automatically instead of changing one of the hatches in AutoCAD. The far I get in here is to produce an access database where I put all the records and I gather all the photographies, but the part of the thematic cartography, I did not reach, okay? But it started the process. How can this be done? So when I have a further experience as coordinator of Gondomar Police Intervention, we introduced, it was in the program, a GIS to do the management of the area. The GIS was the one that was used further for this municipality to develop the global GIS for the council. But in this, with the Esri software, we start to implement and how to manage, how to gather information. So I got many insights how to use GIS. The first experience in teaching was in the civil engineering degree at Lushofen University between 2011 and 2015, where I gave the discipline urban and regional planning in the 3rd year, where we introduced the university has an agreement with Esri. So we used Esri to do analysis, was more close to urban planning, to what geographers do. It was a very interesting experience with the students. At the time, they were discussing, we were here in Porto discussing the location of the bus stations, where will be the best places to put the bus stations. And so the exercise was gather all the information and find where is the best place to put the bus stations. What routes do we have? What kinds of transportation do we have? The main roads, the available land. And so gather all this to produce a report and find the best places. Was a very interesting experience. Further, where then I developed this more seriously. It was in ESAP, where I gave the discipline of geography that makes the connection, as I told before, in the courses of architecture in Portugal as an introductory discipline where you start the analysis of the territory so you can then work with project. This discipline was also always connected with project. I normally work with the students in the same area of project, and we use this as the urban analysis of the place, okay? Then I start using QGIS by a simple reason. QGIS is free. So the students could have QGIS, not so good as Esri, is true, but he has evolved a lot and is very powerful today, and you can use it very well. Also, this does the integration with geography, the normal factors of physical geography and the human factors of geography. And we overlay and cross all the information here. It produce thematic cartography. So it's a normal approach on urban analysis, territorial analysis, and then connected, as I told you, with the discipline of project where students can have this information to do their project of architecture. Further, in the last 2 years, I've been doing the same in geography at Porto University to where I change. The only thing is, as the software is going better, the work that we do is also always also going better. But basically we do the same. The approach is the same that I have done in ESAP. But this is getting more interesting because then I start working with the disciplines of project. In this case, in the third year, urban and integrated project, which is the first discipline that we have that makes the step between architecture and urbanism, where the students have to make the project of a public building, but at the same time to have a large territory. So the beginning was the normal that we do, urban analysis, put all the information, roads, transportation, so on. But then it gets more interesting, but I will get better. I will get to this later. Then in the fourth year in project urbanism, it gets deeper in terms of analysis, okay? For instance, this is already images of this year, where we are working in the municipality of Matosinhos, but in the edge with the municipality of Porto. One of the problems that we have in Portugal is that municipalities don't talk with each other, okay? When you start to work, you have information about Porto, and then you have information about Matosinhos. They don't cross. Okay, so we can use GIS to cross these borders. You can pick information from Porto. This is the urban structure, okay, the ecological structure of both planning of the cities. So we could cross it in here in order for the students to do the project and understand the relations of the territory that is not limited by those boundaries, as you may imagine. And also introduce another factors like demography, okay, which is very simple to do, to understand what are the patterns of people. And also more complex situations like, because the project is very related with connections. And we have in these roads, put the slope for each road, so we can see the difficulty of walking on those areas, and even we have done route analysis to see what is the best route from one station to the one train station to the metro station. How many time, how long do we need? And you see, it's interesting because it is well done. They are doing this because this is the crossbow. Okay. It's strange because they could cross directly, but as the software goes by the routes, it works very well. Then, as I told you, this gets interesting because we have gone, you have gone further in the third year. After that part of urban analysis, the area where we were working, the topography was very complicated. So what we have done all the contours of the area using in GIS old cartography from the 80s, which had more detailed contours than the current cartography. So we have design all the contours in order then to produce a digital elevation model that we could use and understand the topography of the place. Then we have used this to put the several dimensions of the problem. And finally, we have done this. It's a small video where we have used this base that we already have with a plugin, which is QGIS to 3GIS, to then produce these 3D models. And very simple, is extrusion from the project, okay? But with the base, which is the same for every student, at the end, we can compare easily with just volumes, all the projects, all the solutions that the students were presenting. This is the plugin in QGIS. Basically, is a digital elevation model, overlays the image of Google satellite, and then extrudes the polygons from QGIS. This, as I told you, then allow us to compare in the same base the diverse solutions of the students. And also printing the terrain, because another plugin allows us to export the digital elevation model to STL and then to print it in the printer. Then I didn't have done this with students yet, but this idea of crossing this 3D, it's a new trend in GIS. And so I am starting new experiences. Oh, this one is not working. Oh, it's working, sorry. The idea here is also in QGIS to connect with Google Earth Engine. All of us know Google Earth with the 3D images. We can put that also in QGIS. There is a connection. And in the 3D view, I use the example very close to here. It is a square very close. So then in the 3D view of QGIS, you can use the images of Google Earth. I didn't put it yet because I didn't test it, but the same experience that we have done using the QGIS information, the shape files that we have the information, we can put it in here and also extrude it. And further, we have also worked with other software. Blender is a modeling software. And with two GIS add-ons, we can do many work easily. In this case, the add-on is the Blender OSCM that goes to the OpenStreetMap information and brings it to Blender. So you just choose the area which you want. I choose the same. You draw the area that you want to import to the software. You just copy. And then you add this location on Blender. Further, you can import the terrain. It's not a very detailed terrain. And from OpenStreetMap, then you can import buildings. So you have a 3D model in 5 minutes, and you can print it. These are models from the city of Porto, which was acquired by that way. I already showed that some of you, the historical center of Porto. And further, it's probably many of you already know that, the use of SketchUp and Google Earth to do basically the same, okay? The idea now today is to merge all of this. You also can choose the location in SketchUp. This is the connection with GIS. Location is everything. You also import the context area. And you'll head it to SketchUp. I have done a very simple example, very stupid, just to draw what could be a building. I can then save it or export it, the 3D model, as a KMZ, which is the Google Earth file. And then, having this, I can import my model to Google Earth. And see it in 3D. It's not very interesting, the example, okay? But basically, what I was doing here, I can also do in QGIS when I have Google Engine connected. So this is easy ways to start a model. Of course, if you compare this with BIM information and detailed models, it's not the same. We are in these early stages of development, try to see its volumes, etc., work well, especially in terms of large projects, urban projects. Then to end, trends, which are not really, they are today. This is not the future. This is today. The idea in architecture and urbanism about GIS is, of course, urban analysis, production of thematic cartography. It's what we have done lots of years. But in truth, 3GIS, 3D printing are now something which is entering. But most important of all is this, is integration and connectivity that is trying and is crossing everything. CAD, okay, probably for some time. BIM, today, BIM and GIS are trying to work together. QGIS will be difficult, but in this moment, I can tell you that Autodesk and Esri already have done this, okay? If you want to know more, you can see the pages, web pages of Esri, where they already have courses on integrating BIM, Revit in this case, because it's Autodesk, with GIS, having as example the campus of Esri in the United States, where you can integrate detailed models of architecture in the context of GIS. Of course, 3D modeling will be a must. Artificial intelligence, even QGIS, which is a free tool, already have some artificial intelligence. In this moment, you have some tools or add-ons that you can just text like in ChatGPT to find new information. Okay, I already tried. They are add-ons that allow you, for instance, to say, find me all the hospitals in the city of Porto. And then it starts finding me the information and put that in GIS. And of course, real-time data, which is the idea of smart city of Internet of Things, and QGIS already has connectors that allows you to know the sensors in the city of Porto. Open data already has this. You can have the temperature in some parts where there are the stations. You can have metros, you can have buses circulating, and you can put all of this in QGIS. Just to finish a last slide, which is, this is a platform that has been developed. I think it still needs some refinements, but it's very interesting, the concept. Is Speckle, which they have developed several connectors for several software, QGIS, Esri, Archicad, Rhinoceros, Revit, all that work in this environment. And the idea is that you can bring all that information in their hub. So imagine that you draw a terrain, more detailed terrain in QGIS, then you have a Revit model or a Rhinoceros model, and you can bridge them together in the hub and produce a final modeling, 3D printing, so on. Thank you.
Well, let's begin the debate. First, Joaquim Flores forgot the connectivity with space syntax. We worked a lot on it.
Yes, plugging for space.
Hi. Thank you so much, the three of you, for presentations. I have the same question for Efrosini and Joaquim Flores. That is, like, looking beyond the tools that you're using to teach your students. How do you think, how do you reflect on how your course, the course you're teaching, transforms the way students think about their design process? And I mean this, knowing how architecture education works in Portugal, mostly. I don't have much experience outside of the country. But the way people use space or relate in space is not even really a question that crosses students' minds when they are designing their projects. Or they are thinking about architecture and thinking about QGIS, the fact that there exists a social context that outside of the object that they are building is also not something that is often focused on. So I'm wondering if teaching these tools, even if, as Efrosini showed us, students may think they're a bit overwhelming and difficult to use in the, like, right now, do they impact the way students think about design and the questions they ask? Do they start thinking about the Efrosini's experiment? Do they start posing this hypothesis when they are designing? Is this a thing that happen? Have you thought about this? Do you know? Can you say?
No, sorry. Yes, please.
Okay, yeah. So thank you for the question. A lot of things came into my mind while you were asking your question. So one thing is that I think because as architects, we learn through practice, having just one lesson on one tool, it's not enough to integrate and extend, let's say, and extend your abilities as an architect and integrate this tool into one's like body or like as an extension of oneself, because that's how we integrate tools, no? And it's through practice. So I think they need more practice with these tools. But beyond the tools, the role-playing opportunity that, for example, Unity or game engines offer, playing, for example, different roles or different being different people with different intentions, I think they increase the students' awareness on social issues. For example, this week I had a workshop with some students, and I used two users. One was a wheelchair user on Unity as well. On Unity, the same like kind of concept. So one was like a young woman, and the other one was an old wheelchair user. So students had to some students did not develop enough their proposals, so they had to just make some doors in order to play the game. And suddenly they were like, oh, it doesn't work. The user cannot get into the door, or the user cannot come up to this little step that I have here. So I think these obstacles during the process of learning a tool, I think they actually were more significant in their learning experience, because we said, okay, then this door is very small for a person to pass through, or this step is not adequate for people who are not able to walk freely or have difficulties in mobility issues. So I think the reflection on their experience is what actually it's what really matters in these cases. I don't know if I answer your question, but just sort of sharing, what I thought while you were asking.
That's a difficult question. Okay. $1 million question. And I have thought a lot about that. When I introduce these tools, they are really tools. Okay. And I tell the students that they are just tools that help us. Like I told in the beginning, doing in AutoCAD, changing each edge. If I have a tool that it's better, do it automatically, why should I not use it? Why should I, by starting modeling, if I can go to the internet and in 5 minutes? But that's a tool, okay? I don't use it really for project. I use it for analysis, okay? Just to see how the volumes are easily, okay? Not as a process of architecture. And also it's very difficult. It's another problem that I am dealing with. When you have a discipline, geography, which is a small discipline, and then you try at the same time teaching a software, but the software is not important, okay? Software is not important. The important is that they use the software to the things that I'm trying to teach them about urban analysis, territory, and so on. I even told them, if you don't need to learn the software. You can do it by hand. You can do it by AutoCAD. What matters at the end that you have maps and you have to have how to read that maps and what you want to say. If you don't want to do maps, don't do it, but you have to say it at the end in the report. That's more important is the report, okay? But of course, we know if you are teaching a software, it takes time, it's time consuming. And I had a problem, and I'll tell you how I solved. I saw, even if I do it slowly, okay, students, oh, slow, go slow. And I saw that some students were recording me with a phone at the end of the class. Okay, so I didn't say nothing. Okay, it's forbidden, but I understood what was the problem. So I started to do it YouTube channel. Okay, you don't have time. I do it very fast. When you go at home, oh, what was the button that I have to push to do this? I forgot. Okay, it's normal. Okay, it will happen to me also. So I have created a YouTube channel where in this, to learn the software, I put all the small details. Oh, open a file. Okay, starting a project, how to do this, and all of this is in the internet, so the students have access. And when they are doing the maps, they can do there. But it's true, it's time consuming. So I try to balance that. But the main focus is not the software, okay? The software is a tool that helps me. I like very much what Ashik said. Of course, tools shape also the process, of course. Imagine, I think there is a time in architecture before AutoCAD and after AutoCAD, okay? But also imagine architecture of Peter Eisman, Zaha did, without computers, okay? Probably they didn't produce that, okay? So you can see clearly in them how the tool also shapes the process. But in other types of architecture, more traditional probably is not so relevant, okay? AutoCAD does the same as I do when I'm drawing. I'm from the time Ashik also shows people drawing. Well, my course of architecture was like that, drawing with that instruments. And when we changed to AutoCAD, some things, yes, change, but basically AutoCAD is the same. It's an automatic tool to do what you do by hand. No? But when we start with more complex softwares, yes, you can shape in differently the way that you work or produce results in architecture. And so we have to do a lot of reflection about that, because artificial intelligence, all of those processes are here. You cannot say that they don't exist, okay? So it will be replaced for someone that knows how to use AI. Of course, we all know that, but we have to reflect a lot about this. Yes, I think so.
Those methods to the university. Something in the presentation was the evaluation from the students. It was not so good. Well, when the student talks to his teacher, he likes to please the teacher and say, "Oh, you are well, very good." So not 90%, 90% of approval. Well, I saw in the remarks from people, from the students, the difficulty in getting to know sufficiently the software. I think our software for architecture is still not very user-friendly, and well, learning curve is very, very hard. Well, another experience from here, many on our symposium, many of you propose some software they develop, and they don't get to the public because they remain academic software. It's crucial that we simplify the proceedings, the user interface, and so on. I don't know if you want to comment.
Sorry, the quality of the sound was very bad, so I didn't want to interrupt. But
Something on the appreciation of your students, of your games, not so good at all.
sorry, can you repeat again?
The numbers were not so good.
Yes, the results of the evaluation.
Yes.
Yes, I think that the students, well, I didn't hear what you said, but I can just reflect on how I interpret their scores, no? What they rated. I think they didn't feel comfortable in using Unity. And I can understand it. I mean, in 13 weeks, 2 hours per week, I wouldn't feel comfortable either in using, I mean, because it's a very complex software. They are not used to this software. They don't have experience with this software. It's not very related to AutoCAD or Rhino, or it's not a design software. So it's a new world. It's a developer software. So I am not very surprised by this. But I think the positive thing from this, let's say, evaluation was that they could acknowledge the potential that this has, or they could acknowledge the value that the scientific approach has on gathering data on how the environment impacts us. Their reflections on their interpretation of their experiments, I thought that it was really very interesting, because there was a difference. I don't know if you remember the image with the Tatao and the house. There was a big difference in the behavioral patterns, and I think their reflection on what they saw was pretty important, and they could acknowledge that there was a value, a knowledge there. Now, yeah, as I said, I think that they were not very comfortable with the tool because they need more practice. I wouldn't be either, you know. I felt comfortable with Unity the second or third time that I came to use it for a different kind of project. So I don't know if that answered your question. I'm sorry because I couldn't hear your comment. I don't know, I intuitively got what you would.
Thank you very much.
Okay.
Thank you.
I have a follow-up question on this, again, for both of you. So I thought it was very interesting that in your evaluation results, students said they were more likely to use the tool in the future in their own practice than in different design studios. And you interpreted it as being because the tool is difficult to learn and they know they'll need time to learn the tool. But I'm also wondering, is it because these design studios and other teachers don't value what the tool is bringing to the table, what and the scientific method that is behind it? And to Joaquim, it's more or less like, do you have any input from your students on whether they are likely to use QGIS in the future?
Yes. I don't do a survey. I think it's not good policy. Okay, but I have from some students, especially because I enter in the new university in the change of plan. Okay, my discipline was in the third year, then today is in the first. So those 2 years, I have students from the first and from the third at the same time learning geography and GIS. And from the first year, well, they don't know what to expect, so they don't have expectations about software. But once on the third year, they told me why we didn't knew this before. Okay, so many things that we have done that you could we have been doing. For instance, some basic things they use AutoCAD normally, how to put an image, aerial image under an AutoCAD drawing. All of this is automatic in QGIS, but the time consuming about that would be fantastic if you knew that. About the continuity, it's more difficult because, as I told, GIS will not be a tool that probably if we are doing regular practice in architecture, they will use. Okay, in the current state, as I have 3 disciplines in first year, third year, fourth year, I massacred them with GIS. So when they start in the third year, they have to do urban analysis in QGIS. So when they start in the fourth year for urbanism, they also have to do analysis in QGIS. So I think most of the students will forget, okay? But at least they have a base, and someday, if they need in the office, they will say, oh, how it is, they know where it is, they can pick it up. But I have also the experience of some students I have in the 4th grade that they are working fantastically. They are working students, okay? And they have already introduced that in the office, okay? Doing the bridge between AutoCAD and GIS. There are things that are better in GIS. So you can do it, and then you can bring them to CAD and so on, okay? And the ones that understand that, I think with time, we'll get there.
Something else?
Yes, so to respond to the question, I think that students understand that it's an investment to do a behavioral analysis, let's say, of your building, or an evaluation in that sense. So if it's not required for a design studio, they won't do it. They would do it, for example, as they said, because they acknowledge that it's a good tool in case of an architectural competition, where there is a competition, where investment in what you present, it's might give you a reward, no? So also in future practice, I mean, some comments were there, I would do that sorry, I didn't include that in the presentation, but students in a question where I asked them, where do you think you would use this? They said that for a big client, for example, and a big project, or a very big project, to see how people would behave, how people would move in that project. In their studios, they have a very limited time and they have to learn how to design. So that's their priority, I think. And having seen them, the level of how quickly they I mean, it's still like more than half of the term has passed and they're still in a very conceptual phase. So it depends on where they are. So I think they acknowledge that they reach at a level where they can do this kind of analysis just 1 week before the submission of their proposal, I think. So, and also at the final year, I think they have to present in a very limited amount of time for them, for how they perceive, I think, their experience. They have to do a lot of work. So they wouldn't include an additional thing that is not required. So that's how I interpret these results of the questionnaire. No, I hope that answers your question.
Hello, hello. Okay. Well, first of all, thank you very much, Joaquim, for your presentation. It was really, really interesting, and of course, I think the issue here is about how strong ideology can be shaped by technology, and basically, well, I remember that more than 10 years ago when I was teaching at Galésia at the time, I put students working for the first time with models of terrains, and we, instead of the curves that we usually use, we were taking the basic points that were the result of the surveys of the terrain. So all the models were triangulated. So it was easier and more precise at the same time. So building the models was something that changed drastically with that, the speed of the students. And also because they had that inside of the computer, it was easier to them than to insert the buildings and to study the topography in general. And of course, this kind of teaching, it consumes time, and I think that, well, like in all different areas, we have a problem with, for example, we teach CAD inside of schools, like if it was something separated from the rest of all the other issues that we have inside of the course of architecture, for example, or design. And maybe it's happening the same in all areas, that we have teachers that instead of learn what they call research, is basically doing papers and not real research, because basically computer science is not, it's not an area separated from all the other areas. Computer science is everywhere, and so we should have probably structures with computers. Probably, well, project that is the main discipline in architecture. It should be taught from the beginning with these kind of tools that they are not, they insist in call it modern technologies or novel technologies or advanced architecture. In fact, it's contemporary tools for 20 years now. And I'm really, I'm thankful that, for example, when I did my course in Lisbon, At that time, I don't know now, but we started from the first year with CAD, and we had 2 years of CAD. So CAD 1 and CAD 2. And only in the end of the second year, I realized that this is definitely the future. This is it. This is what will happen, because they teach us how to build in 3D, how to think in 3D. And then, okay, then we can slice the buildings, I can slice the terrain, and we have all the blueprints that you need to please the teachers in this case, because in fact, that's the only thing they could understand at that time. And basically 20 years later, we are more or less in the same step, unfortunately. So for me, it was really interesting to see that something is changing, and I hope that you will be less and less isolated in your research. Thank you very much.
Well, thank you. Not much to answer, just to say yes. I also learned with traditional methods, and then I have to learn myself with AutoCAD. AutoCAD, which is the basic tool that we started now. It's out of dated, I think. Not so out of dated as Franklin is always saying that BIM is the top and so on. Forget CAD. I still think CAD has a role, at least in the beginning, in the transition of normal drawing, can say, and drawing, because it's a natural tool. But they have some, even AutoCAD, which is a very simple tool, have some problems. I like to tell a story about an architect, which is Bernardo Tavra, that once made a conference, and they explained me that he have new trainees in his office that were very good at CAD. They were drawing in metro project that he was developing, and they have details of a bathroom that you were designing. Fantastic, everything was there in detail. But then it's not possible to open the door because the door is going to against the sink. Okay, it was not possible. Why? Because this is a problem of being in the face of a screen. Okay, if you don't have a bigger thought about it and not think that as a tool, it can help. Of course, so the great challenge in all those softwares, yes, is how to put that in the philosophy of project. Okay, and how can we merge that situation? I don't know how to do it, but I think it's.
Can this panel? I thank you, everybody, particularly our speakers. Thank you very much. And well, we are half an hour later. Okay, we are an half an hour later, but please go to the coffee break. Thank you.
Thank you. Bye.